Hey you guys, this video is going to be a quick introduction to 9.1, which is about sequences. Before we get started, I wanted to kind of just talk to you a little bit about the calendar for this unit. We really just started Chapter 9. It's actually Unit 10, but it's Chapter 9 before Minimester, and I know a lot of you weren't here on that day when we started with sequences. We only did 9.1 right there um, on the day before, and I think there was 4 of you there. So the rest of you guys are going to have to make up. This will be the actual assignment. We're going to call it due Thursday, the same time that 9.2 will be due. Um, but I wanted to kind of show you the rest of the calendar. So we go through really kind of the first half of Chapter 9. And then we'll take a quiz right here on the 23rd. And when I say it's the first 5 tests, there are basically 10 tests for convergence of a series. And so that's what I mean by the first 5 tests. The integral test, P-series test, direct comparison, limit comparison, alternating series, and so on. So we take that quiz, and then we do several more tests. We do what's called the ratio test and the root test. And there are several, and then we start into the second half of Chapter 9, which is right here when we start doing Taylor polynomials. And we will go through that week, and then notice that we'll have another quiz here on the 2nd before we finally finish this chapter and take a test on the 9th. Now, this is something that I know I've mentioned to you before, this is a big chapter. The majority of the AP questions that are BC come from this chapter. So we have to kind of cruise through it, but we need to make sure that we are doing a constant back and forth despite this schedule that we're having to keep, and I don't know how long we're going to have to be working through this distance learning. We can do it. We can make it work, but it's going to take both of us. I'm really going to have to keep an eye on making sure you understand, and you understand for the right reasons. I know it sounds like we're on The Bachelor or something like that, but I mean, a lot of these, the answer is simply converge or diverge. And so, I mean, I guess if you think about it, you got a 50% chance of getting it right if that's all that they're asking. But we need to make sure that you understand why it's converge or why it's diverge, because they're starting to write the questions in such a way that it's not just about converge or diverge, but do you understand why? So anyway, that was kind of a 3-minute long introduction that you probably don't care about, but there you go. So when we start to look at the notes, basically I'm going to talk through a PowerPoint, just like I would normally be doing in class on this. So section 9.1 is sequences. And basically you need to know a sequence is simply a list of terms. That's it. It is just a list of terms. You'll notice right here the notation for a sequence. We tend to use braces. Okay, notice what I'm talking about, braces. And then A sub n is just a notation. So the first term would be A sub 1, and then the second term would be A sub 2, the third term would be A sub 3, and then A sub 4, and on out to the nth term. So if I wanted A sub 10, if n equals 10, then we would have 10 terms. And since it's just a list of terms, notice they're separated by commas. We're not adding them, we're not multiplying them, we're just listing out individual terms. That's what a sequence is. Just as a matter of vocabulary, n, the n that we show up here in the A sub n, is called the counter. So for example, we might be talking about a sequence that's defined as 2n over 1 plus n. Well, just start listing them out. Think about if n equals 1, if n equals 2, if n equals 3, and so on. So if n equals 1, the first term is just simply going to be 2 times 1 over 1 plus 1, right? Wouldn't that just equal 1? Because let's see, 2 over 2 is 1. If n equals 2, right, you're going to have 2 times 2 is 4 over 3. If n equals 3, you're going to have 2 times 3 would be 6 over 4. And yes, of course, you can simplify that. I just wanted you to see where it came from. And then if n equals 4, you'd have 2 times 4 would be 8 over 5. And so we're just listing out the terms. So, sequence is a list of terms. A sequence, we say a sequence converges if the terms approach a limiting value. So when you list out the terms, if you can tell that they start to level off at a specific number, then we would say that the sequence converges. So here's where the calculus comes. That means the limit as n approaches infinity of that sequence equals L, meaning it equals a specific limiting value. So when we say L, we're saying L is a specific constant, right? If the limit equals a specific constant, then we say that the sequence converges. And so vice versa, a sequence would diverge if the limit doesn't exist. In other words, if they don't level off, if the terms don't level off, then we would say the sequence diverges. So, since all of this is about limits at infinity, we need to make sure you understand how to do limits at infinity. And I know we've done them in different ways, but let's kind of put together a list here of the different things we've done. So, first thing you should try is just substitute in infinity. I mean, isn't that how we do limits? We substitute in. We're just not used to substituting infinity. And keep in mind, when you do that, a lot of times you're going to end up with that topic that we talked about where a constant over infinity equals 0. So, for example, I think we've talked through this, but just for example, like I might say, hey, what if I have 1 over 100? Well, if the denominator is bigger, say 1 over 1,000, and maybe the denominator is even bigger than that, say 1 over, a million, then essentially as the denominator gets closer and closer to infinity, then doesn't the value of the whole fraction get closer and closer to 0? Okay, so keep that notation in mind. That kind of tends to come up on these. The other thing is, when we evaluate limits at infinity, isn't that the same as horizontal asymptote rules, where you compare the degree of the top and the degree of the bottom? Now, something to keep in mind, those horizontal asymptote rules only work if you have a polynomial over a polynomial, right? Horizontal asymptote rules don't work on all kinds of functions. All right, we recently introduced L'Hopital's rule. So if when you substitute you get indeterminate form, and remember indeterminate form is 0 over 0 or infinity over infinity. If you get that, then you can do L'Hopital's rule, remember, where you can take the derivative of the top and the derivative of the bottom. Another one that we haven't really used much in reference to limits, but I'm going to throw it out there because sometimes it's helpful, is partial fractions. If you start off with, say, some big old fraction, and you notice that the denominator can be factored, you might go ahead and use partial fractions, where you write it as 2 separate, and that might help you to be able to simplify your limit. And then ultimately, you can always just think about listing out the terms. If you start listing out the terms, can you tell that they're going to level off? Now you're kind of taking an educated guess sometimes when you do this, so you have to be careful with this, and really this should be your last option. But it can be helpful just to list them out and see if they approach that limiting value. Okay, so let's look at some examples. Determine whether the following sequences converge or diverge. So I wonder why I started with number 1 or number 2. Oh well, when I look at this example, number 2, what I need to think about is, hey, we need to take the limit, right? Because that's how we determine if a sequence converges or diverges. Well, if I take the limit as n approaches infinity, wouldn't this be one where you could do your horizontal asymptote rules? And so if you did that, you have the same degree. Wouldn't you just get 2 over 1? So since the limit equals a constant, that means the sequence converges. All right, look at the next one. So again, we take the limit. Now, this is one where we can't use horizontal asymptote rules, right? Because this is not a polynomial over a polynomial. 2 to the n is not a polynomial. So what might I try? Well, how about we substitute? If we substitute, right, we're going to get infinity over infinity. Oh, that's indeterminate form, right? So we're going to use L'Hopital's rule. So if I take the derivative of the top, derivative of n squared is 2n. Now remember, 2 to the n, remember the rule, the derivative, I should probably move this over, shouldn't I? The derivative of a to the n is itself times the natural log of a. So the derivative of 2 to the n is 2 to the n times natural log of 2. Okay, so now when we substitute, don't we still have infinity over infinity? Well, Good thing about L'Hopital's rule is you can do it again, right? Derivative of 2n is 2. Now think about it. This natural log of 2 comes down because it's just a constant. And then when I take the derivative of 2 to the n, I'm going to get another 2 to the n natural log of 2. And so now if I substitute, aren't I just going to have 2 over infinity, which we talked about before comes out to equal 0. Okay? Look at the next one. If we take the limit, oh, sorry, so that one equal to constant, so we say it converges. So on number 4, if we take the limit, if we go ahead and substitute, won't we just get 1 over infinity, which is 0? Okay, so that one converges. So does that mean they're always just going to converge? Oh, you know better than that. So look at the next one. Take the limit. Now, this is not horizontal asymptote rules. If I substitute, I get 3 plus, and here's the thing, negative 1 to the infinity is not infinity, right? Negative 1 to any power is either going to be 1 or negative 1, isn't it? Depending on if that exponent is even or odd. So why don't we list out some of the terms? Think about it. If n equals, what do we want to start with? If n equals 1, then I would have negative 1 to the 1 is negative 1. So wouldn't the whole thing equal 2? But if n equals 2, if n is even, then negative 1 to an even power is going to be positive. And so I add that to 3 and I get 4. And so do you see, because it's going to alternate being an odd exponent and then an even exponent and then an odd exponent and then an even exponent, the terms are going to alternate from 2 to 4 to 2 to 4. Well, that's not leveling off. We don't say that it's leveling off at 3. Actually, it's oscillating, right? It's going from 2, 4, 2, 4, 2, 4. It's jumping back and forth. And if it oscillates, then the limit doesn't exist. So this would be one where we would say that the sequence diverges. Okay, number 6, I'm curious, does that look familiar at all? We barely mentioned it a while back. We actually said that that limit comes out to equal e. It was one of those that we went all the way through and I said, hey, it just comes out to equal e, and you can look at the work if you want to, but I wouldn't worry about it. I would just recognize that pattern. And since it equals e, that's a constant, so that means the sequence converges. And then look at the next one, this n factorial, right? The exclamation point means factorial, and have we talked about factorial in this class before? Sorry, I'm losing it, you guys. Remember, factorial means basically you multiply your way down. So, for example, 3 factorial means 3 times 2 times 1, right? Which would equal 6. Or you could say 5 factorial means 5 times 4 times 3 times 2 times 1. So that would be what, 20, 60, 120, I think. You can check my math, I can't remember. You'll start to get familiar with a lot of these factorials because it's going to come up quite a bit. Anyway, whatever the case, if I substitute, I'm going to get infinity over infinity, right? But yet, I can't do L'Hopital's rule because I don't know how to take the derivative of a factorial. We're never going to know how to take the derivative of a factorial. It's not horizontal asymptote rules. So let's think through some terms. If n equals 1, 2 to the first over 1 factorial is 1. If n equals 2, we're going to have 2 squared over 2 factorial, right? It's going to come out to equal 2. Oh, hey, are they all going to equal 2? Well, if n equals 3, I'm going to have 2 cubed over 3 factorial, which actually simplifies to be 4/3. And we could, go through the math, but I'm just going to kind of show you. If n equals 4, if we do the math, that'll simplify to be 1/3. And I'll go one more. If n equals 5, right? We got 32 over 120, and that'll simplify to be 4/15. Is that enough to show that I went from 2 to 2 to 4/3 to 1/3 to 4/15? Do you see that the terms are getting smaller? And do you see that the denominator is basically getting larger faster than the numerator? right? The numerator is increasing and the denominator is increasing, but isn't the denominator increasing a lot faster than the numerator, which means these terms are essentially going to 0? Okay, so if the limit equals 0, then that means it must have converged. Okay, so there's something else to consider. Yeah, it's called the absolute value theorem. You don't need to think of it as a theorem, but the idea is, what if you're taking the limit of some term that's positive versus some term that's negative? Well, if you know that the limit equals 0, um, so absolute value would mean it taking the limit of a positive term. So the idea is if you're taking the limit of a positive term and that equals 0, then basically it doesn't matter if that term is positive or negative. That means that the limit of just the a to the n equals 0, which is kind of confusing, but I think this really kind of sums it up. In other words, it doesn't matter if that sequence term is positive or negative. If it approaches if it goes towards 0, then it doesn't matter. Positive or negative, it's going to go to 0. So here's kind of a good example, I think. Determine whether the sequence converges or diverges. Well, think about the limit, right? And here's like what we were talking about before. If n is an odd number, this is going to be a negative term, right? But if n is an even number, this is going to be a positive term. And so because it's going to be either 1 or negative 1, right? Either 1 or negative 1 over infinity, it doesn't matter if you think about it as being positive 1 or negative 1. It's going to equal 0. And I don't know if this is helpful or not, but think about it this way. So let's say we're talking about n going out to, I don't know, out to 10 or something like that. So if n is 1, we're going to have negative 1 over 1, right? If n is 2, we're going to have positive 1/2. Let me stretch out. Let's say here's negative 1 and positive 1. All right, so if n equals 1, we're down here. If n equals 2, we have positive 1/2. If n equals 3, we have negative 1/3. If n equals 4, we have positive 1/4. If n equals 5, we have negative 1/5. So do you see that even though it's alternating positive and negative, they're still getting closer and closer to 0, right? So it didn't matter if it was a positive or a negative term, the fact that it was going towards 0. So this sequence is going to converge. So 9.2 is series. That's the next topic. So I want to, whoops, I don't want to keep my annotations. I want to take you back to the homework, and I should have mentioned this earlier. You may not have the blank copies of the notes, but all of that is in Canvas. So if you have a printer, you can print it off. If you don't have a printer, then you have to go old school and just kind of take notes, do homework on your own paper. This first half of the chapter is problems out of the textbook, so it's not that big a deal to do the homework on your own paper. You've kind of gotten spoiled in that I've, given you the paper, but you might have to take care of that yourself. So if you look at the homework, and on the calendar it lists out what the problems are, so you might, I've given you kind of the whole page out of the textbook, so you might have to go in and, circle the ones that you're supposed to do, because, we certainly don't want to do anything extra. So, circle, you're going to do 2, 4, 7, and then all of 15 through 18. That's this matching right here. 29, 31, 33, 29, 31, 33, and this is all about simplifying factorials. And then 47 through 67 odd. So basically you're going to go here, down, I'll let you take care of that, doing the odd problems. So I do want to mention just a couple things. Just first of all, make sure you read the directions, right? The first couple ones are just writing out the first 5 terms, which may sound like a trivial task, but it's just helpful to get an idea of how, you have your list of terms. But I want you to look at 15 through 18 because I think it's kind of telling as far as understanding what's going on. So it says match the sequence with its graph. Well, to me, the easy way to match it with the graph is to look at where it's leveling off. Like if I look at 15 and I think about the limit as n approaches infinity, use your horizontal asymptote rules. Wouldn't this one level off at 0? And so do you see that for letter C, all of the terms are leveling off? Whoops, that was kind of a bad graph, but all the terms are kind of leveling off at 0. Now, letter B is also leveling off at 0, but do you see that it's positive and negative? It's kind of back and forth. So does it make sense that if you look, that's like the one that we just talked about. If you look at number 18, isn't this one going to be like negative 1, and then positive 1/2, and then negative 1/3, and then positive 1/4? And that's kind of what we talked about for letter B. And let's see, we said number 15 would be letter C. So think through those, not just by elimination, but think through those based on where it's leveling off. Okay, and then I want to mention up here, when you simplify factorials, we don't want you to have to do the math. For example, think about number 30. If you had 25 factorial, so 25 times 20, whoops, 24, sorry about that, times 23 times 22 times 21 times, and then you still have your 20 on down, right? Let me scooch this over so you can kind of see it. So you still have your 20 factorial on down. And then if that's all over 20 factorial, wouldn't the 20 on down cancel the 20 on down? So it's just going to become whatever 25 times 24 times 23 times 22 times 21 is. So just wanted you to think about that. As far as simplifying factorials, you can usually slash out a whole bunch of them at one time. So like, for example, on 32, if you have n plus 2, well, the next number down would be n plus 1. And the next number down would be n, and then on down, right? Well, if that's all over n on down, can't you slash those, and what you have left is just n plus 2 times n plus 1. So that's kind of an easy way to simplify factorials. And then it's when you get down here to number 47 through 67, those are the ones where it says determine the convergence or divergence. So in other words, evaluate the limit. Now some of them are tricky, some of them are kind of thought-provoking. I'm going to let you try those. And then in the, I'm thinking in the next video, and also I'll have my answers posted, we can kind of discuss questions, and maybe you can kind of send me some of your questions, and I can kind of put together a video of some of the most commonly asked ones that'll kind of help you out with that. Or we'll possibly, like I said, on Thursday meet in some kind of a Zoom conference where we can kind of talk through some of those. All right, so good luck with those. Try that assignment, and let's see if you can, those of you guys that need to get caught up, let's see if you can get that turned in by Thursday.